Welcome back to the second part of my tutorial, how to perform polynomial regressions with surface analysis. And now we will perform the actual polynomial regressions. In the first part, which was a previous video, I already showed you how to identify whether we have enough discrepancy in our data in order that we can actually analyze it. And now actually I want to test this model. So just short again as repetition, I want to see how buyer trust and supplier trust have an influence on perception differences. And the two independent variables are called x and y in polynomial regression and the dependent z. And we take a look at what we have to do. The second step in the polynomial regression is that we center the independent variables, which are in our case the buyer trust and the supplier trust. And this is a little bit not clear in literature because normally centering means that you center around the mean. So you actually deduct the mean from the data you have. But in this case, we want to center around 0 and we want to center the scale around 0. So when we would have a 5-point Likert scale, we subtract the numbers by 3. When we have a 6-point Likert scale by 3.5, and when we have a 7-point Likert scale with 4. In this case, in my example here, we have a 6-point Likert scale, so I center by 6 point by subtracting 3.5. So let's get to it. Let's go to the file again. I open again. I center by computing, by going transform, compute. Then I delete the stuff I used in the last video. I press here the right mouse button to show me the variable labels, the variable names again, to make it easier for me to see which constructs I want to choose. So I need to have I begin with the supplier trust, this variable, and I want to subtract 3.5, which is for my 6-point Likert scale. And I call this variable, I name this variable supplier trust centered. Very good. And then I press OK. We see SPSS said execute, everything is good. We do the same for the other independent variable. So we go again to compute variable. This time I take supplier trust away. I scroll down again and search for buyer trust. Where do I have the buyer trust? Buyer trust, I put it in here, and then I change this one to buy trust centered. I press OK. SPSS said everything is good. We can also take a look again in our file. So I go back to the regression, to the SPSS, and I see I have a variable supplier trust centered and have one buyer trust centered. Then we go back to our Excel, to our PowerPoint, to see what is the next step. And this is the equation. On the right, we see the equation of polynomial regression. And we see that next to our centered x and y, to our supplier trust and buyer trust, we also have need to have a squared x, and then the interaction between x and y, and then a squared y. And that's actually what we do now. So I go back to SPSS, again to transform, compute, and then I take this variable. So I copy this one, makes it easier. And then I say, okay, I time this by the same. So we actually can also find the same variable here. So when you can also just press from here and here, and then you have the same. So I make it squared. So I will call this then squared. So I know, okay, buyer trust centered squared. That is the new one. Buyer trust times buyer trust. Then I say, okay, SPSS says, I like it. You can do it like this. I go back. I do the same for supplier trust. So I take these away. I go down to supplier trust, put it in, multiply again, supplier trust. And then I call this supplier trust centered squared. Press OK. SPSS is also fine with that. And then we go to the last one, which is transform, compute, and then we make the interaction term of the supplier trust and the buyer trust. That's the last one we need. So we take the buyer trust is here, put it in here, and then I say sub by trust centered interaction. And then I take a look, everything's good. Supplier trust, buyer trust, supplier and buyer trust interaction. I say okay. SPSS said it's fine. Take a look again in my SPSS file, see whether all of these are actually really there. Yes, I can see here they are there. Yeah, here the variables. We can also recheck here again. When we, for example, buyer trust centered, it's -1 squared, it's 1. The supplier trust is 4, so everything is fine. And also the interaction 1, 2 times 1 is -1. Sorry, -1 times 2 is -2, of course. So that was the third step, which we performed, or the second step in this video actually. And so we did the square terms, we did the interaction. Then now we go towards the real analysis. And so step 4 is that we actually really perform the regression with all the 4 variables, which means we take the buyer trust, the supplier trust, the squared buyer trust, the interaction of the two, and the squared supplier trust here in this case. You can also add actually what you see in this figure here and in this table here. You can also add in different steps in the regression also control variables. For the moment, I don't do it here. I'll just show you how to do a normal regression, but in a hierarchical regression, you can actually also add control variables. And what we have to take care of when we choose the regression, that we also request covariances, because they will become more important when we soon open the Excel file, which Shanok is providing for actually really creating the response surface and for the analysis. So we go back now and perform the regression. So let's go back. We say analyze regression, and we say it's a linear regression. We take our dependent variable and we go back to our model here. That's what I want to test. I want to see buyer trust, supplier trust, and perception difference. So what I do now is that I search, so right click on here, and then display variable names so I can see it better again. And then I search for my variable, which is the difference in, it was preferred customer. That is like difference in perception. I say difference of preferred customer stages in my case. And then I go down and I include all my variables. This is the centered trust, the centered supply trust, buyer trust, then the squared terms and the interaction. When you press Shift and you press down here, you can mark them all at the same time and you can put them in here. I choose everything as default, enter method. Of course, when you would want to include control variables, you would first include them here, then press next and include these variables later. And then I also want to have some more statistics. You can also ask for example, multicollinearity diagnostic when you want to see whether you have multicollinearity in the data. You can also take a look at a little bit more aspects. But actually, the most important thing in here is the covariance matrix. Actually, you do not need to take these, but more or less the covariance matrix. I normally always take these. Also to just take a look whether the model is good. Then I press OK. And then I say, OK. Then SPSS is working hard for us and is actually giving us all the data we need. So now the next step is actually when we have the data to go to the file, to the Sherlock Excel file. And 1 second, I have just to open it. Yes, and we can already see here when we, while the Excel opens, we can see, okay, what is the R square? The R square is actually very, very nice, 0.27. The model is significant. We can see these are actually quite high variance inflation factors, I have to say. So we might have, in this case, maybe a problem with multicollinearity, but that's something which would be I need to discuss further in the paper. And here we have also the covariances, which will be important soon. So we open the Sherlock, and then we can say how we call X and Y. X, we said it's supplier trust, and this is, sorry, X was buyer trust, of course. Buy trust, and I better check again, not that I make a mistake. Yes, X is buyer trust, Y is supplier trust. So here take supplier trust. Yes. Then I put this on this side so that I can see it a little bit better. Correct. And I put this on the right side. I hope this works, that we can still see everything. Right now we see there's this flat surface. Normally there's no naming in it. It just says Z by Z, Y, and X. You have to name everything yourself here. You might also need to change the scaling here. For example, I, in my case, need to change the scaling. Also of this, I actually need to change it to 0, 1, 0, 1.5, and 3, as far as I remember, yes. So I also need to change the scaling here because my scale is a little bit different. Correct, but for the moment, we just fill in these data. So we go above, so we go down, and down ANOVA we see it's a total DF of 124. So I actually put in here 124. Actually, the number is now a little bit lower because the degrees of freedom are, of course, always a little bit lower than the sample size. And so I think I have 129 cases, 127 cases, but right now I just put 124. Then the constants, and I go down here. And here we have the betas, and here it says unstandardized betas. So what do you see here? Unstandardized. So for the constant, we see it's a minus 0.915. For x, it is a minus 874. Minus 0.874. Then we also have to put the standard errors, which we find here. And then it would be here a 0.429 for y. Oh, actually, I switched it to. I shouldn't have done it. So I just copy paste them here. Because I said Y is supplier trust, and here it's mixed. So then I go to buyer trust, which is 0.795, and the standard error is 0.345. Then I say x squared, which is the buyer trust squared by a standard, that's minus 0.030, and the standard error is 0.118, as we can see here, these two. Then we go to x and y, which is here, supplier buyer trust standard interaction. Then that is minus 0.052 and 0.152 for the standard error. Finally, we have y squared, which is here supplier trust, which is 0.276 and 0.124. Now it comes down to also have the covariances, and here we have to go down to this table, which says covariances, and then we see here again the different variables, and the same variables are repeated here at the top, as we can see. And we have to check for B1 and B2, and when we see here B1 and B2, is the first one is X and Y, which is buyer trust and supplier trust, which are we have always to see, because here in the covariances it sometimes tend to mix things more up. So what we see here now is that we search for buyer trust and buyer trust centered with supplier trust centered, which is the 0.050. Then we have B3, which is x squared, so buyer trust squared, times B4, which is the interaction. So we have to have buyer trust. Oh, here we have already the interaction. Oh, I better go with this. So it's buyer trust squared, and then the supplier trust centered interaction, which is this. Here's the interaction, which is buyer trust. So this is B3 squared with B4, which is minus 0.004. Minus 0.004. Then we have B3 and B5, which are the two squared, the x squared and y squared. So we have to take a look at supplier trust centered squared with buyer trust centered squared, which is actually this one. Oh, no, sorry, this one. So it's like supplier trust centered squared, buyer trust centered squared, minus 0.002. Minus 0.002. And then finally B4 and B5, which is the interaction and the squared supplier trust. And here we have the supplier trust, and we have the interaction, and this is this interaction, this supplier trust, and it is 0.003. 0.003. And when we filled all of this in, we see that we see nothing right now, apparently. But this is also the case because I have to change the plots here, which is 5, 3. Yeah. We see that one is significant here. The slope is significant, but the interpretation of this figure, I will make another video for it. Here we have to change now the scale. The easiest way to do is I have a 6-point Likert scale, and how I think about it is that I have to first subtract a 1, that the whole scale, because I have a scale from 1 to 6, and then the scale is from 0 to 5. And then I know, okay, how I have to change it. In this case, then it would be, when I subtract a 1, then it would be 0 to 5, and then half of it is 2.5. So actually here, this must be at minus 2.5, 2.5, 1.5. 5 and minus 1.5, and here the same 2.5 minus 2.5, 1.25, minus 1.25 and 5, yes, correct. And this is this. This is, of course, because I had a different score, and my different score goes also below 0. That's why the scale looks so awkward. And that's also something you might need to do, that you click on the plot area, format axis, and then you say, well, the minimum, the maximum, I just say reset, reset. You could go from, let's see what's the best approach, from maximum to minimum 6. And I will keep the other the same. I think the major units are okay like this. Let's see. Actually, this looked a little bit nicer. This way you can name the variables, like this is the difference of preferred score. This is actually mixed. This should be the supplier, and this should be the supplier. As also indicated here at the top, X and Y, I wrote it down here, so that helps me to identify again what is X and what is Y. And then I can interpret this figure. This is how you do a polynomial regression. And then how you can interpret this figure, I will explain it to you later, maybe also with some other examples, because this is not the perfect example, but we can see here that this slope here from from 2.5 to minus 2.5 of the supplier, and the buyer, which is also minus 2.5 here and plus 2.5 here, that it goes up. So it seems there is some sort of linearity in this, which is indicated by significance. But I will explain this in a video later. This is how you perform a polynomial regression with surface analysis. Thank you for watching. And when you have questions, you can always contact me via these email addresses or call me. Thank you very much.